Hello. We're going to talk about equations with variables on both sides. I know we've been building up to this a little bit, so here we go. Just a couple of examples. All the skills that we've done with solving equations before are still applicable. Inverse operations are still inverse operations. We are still trying to get the variable terms on one side, the constant terms on another. So as we look here, we have a variable term and a constant term, a variable term and a constant term. We want to get things into this before we start to take things to both sides. So let's take a look at this first example. I'm seeing a negative 2x over here. The inverse of that is to add 2x to both sides. So we'll go ahead and do that. 7x and 2x is 9x plus 19 equals 55. Okay, we have a variable term and a constant term, and then a constant term 55 on the other side of our equation. So we do need to take this 19 and slide it on over to the other side here. So we will subtract 19 from both sides. So if we were to subtract 20, it'd be 35. This looks like this is going to be 36. I get 9x is equal to 36. And as is most often the case, our last step here, 9 times x, the inverse of that is division. We'll divide both sides by 9. I get x is equal to 4. Now you will be required to go back and show the check. We'll touch base on those during class time tomorrow. But please notice how I work through these problems. This is the most efficient, easy to read, easy to follow way, and this is how I expect you to solve your equations, one step at a time. Let's take a look here. Constant term and a variable term, and then a variable term by itself. So that makes me just want to add 9x. It'll help me be more efficient. I'll have 80 is equal to 15x. I could have subtracted 6x, but then I would have had a couple more steps than I would this way. This becomes a two-step equation. The inverse of multiplying by 15 is dividing by 15. 80 divided by 15 is 6, and that is equal to x as my final answer there. As we're getting variables on both sides of the equation, there will be two special cases. There will be a no solution and an infinite solution. You go about solving these in the same way as those two examples that we just did, but the ending will be slightly different. So if I look here, I'm going to try to get my x terms together on this left side, so I'm going to subtract x from both sides of this equation. Well, x minus x is 0. I get 0 plus 2. X minus x is 0. I get 0 plus 4. That ultimately gets us 2 is equal to 4. Well, this is false. That's not true. Okay, so there's no solution. Okay, no solution. And we get that based on this right here, the 2 equals 4. That's not true. We come over here, we have, as it says up top, it's infinite solutions. We have to simplify the left side. I get 3x plus 6 is equal to 3x plus 6. Well, hopefully you notice something now, that those two sides are equal. We are going to do one more step because they won't always just stand out like this to us. So we'll subtract 3x from both sides. 3x minus 3x, those cancel. I get 6 is equal to 6. That's true. Okay, that means there are infinite solutions. And what that means is you can substitute any value of x in there, and it'll make that equation true, no matter what value of x you substitute in there. Getting into a little bit more complicated equations, we have some parentheses, we're adding something in here. So again, we just have to fall back on everything that we know to this point, the distributive property, combining like terms, those types of things here. And we'll start off on this problem by distributing on both sides here. I get 4 minus 4x plus 3x is equal to negative 2x minus 2. Now, before we start to take things onto both sides of the equation, I need a constant and one variable term. A constant and one variable term. So the right side here is good to go. We're good to go over here. Okay? However, I have to combine these two terms right here. Negative 4x and 3x. Since they are on the same side of the equation, I just combine them together. So that'll give me 4, negative 4x, and positive 3x is minus 1x is equal to negative 2x minus 2. Common mistake here would be to maybe subtract 3x or to add 4x. We don't do that because they're on the same side of the equation. Now we are in a position to where we can start to combine the variables on one side and the constants on another. I'm looking here. I'm going to add 2x to both sides. That'll give me a positive x term here. I get 4 plus x is equal to negative 2. From here, I have positive 4. That means I need to subtract 4 from both sides. Cancels that out on the left and leaves me just with x is equal to negative 6. Again, once we distribute and combine like terms, this problem becomes the same as all the other ones that we have been working with right now.